Hey folks, in this video we're going to talk about KEQ, how it relates to equilibrium. So KEQ, the way that you actually write it is you give it a capital K and then usually it's a subscript EQ. And what this is used to do, chemists usually use this nomenclature. The capital letter is just K for constant, which is really dumb, but that is what they came up with. And then the lowercase or the subscript letters, those are to describe for you what type of constant you're dealing with. So if we have an EQ, we're dealing with a constant of equilibrium. And as you progress through chem, you'll learn things like KW, KB, KA, KSP. And so KW would be K water, constant of base, constant of acid, constant of the solubility product constant. Those are the different types of constants. And what we do with the KEQ with related to equilibrium is it gives us a constant number to be able to predict what concentrations will exist at equilibrium. So the KEQ is always represented by the concentration of the products divided by the concentration of the reactants. And so what we know then is there's a couple different things that we can derive from this. If the KEQ is equal to 1, we know that we have the equal amount of products and reactants. If KEQ is greater than 1, we know that we have more products. And if we compare that to the fraction here, we would know that if this number is bigger, if the products number is bigger than the reactants number is, well, we're going to have a fraction greater than 1. So in other words, if the KEQ is bigger than 1, we'll have more products. If the KEQ is smaller than 1, then we know that we will have a reaction with more reactants. And so what this can do is tell us if a particular reaction will be reactant favored, product favored, or neither. This KEQ is equal to 1 doesn't really happen very often, but it does exist, and so it's worth talking about. We can also have KEQ numbers. If KEQ is equal to 10 to the power of minus 10 or 10 to the power of positive 10, we say that that reaction goes to completion, that we basically have all products if our KEQ is 10 to the power of 10 or bigger. If our KEQ is 10 to the power of negative 10, then we say that the reaction basically doesn't happen, that we have so much reactant that realistically there's not enough product to really even classify this as a reaction. And so what we're going to do is we're going to show you how the KEQ works. And I did this equation up above here. And I'm just going to move this equation down for us so that we can go through it together. So this equation here is 3 calcium hydroxides reacting with 2 Na3PO4s, and then is reacting to produce Ca3PO4 and 6 NaOH. And so as we said, the way that we represent KEQ is the concentration of products over reactants. And so what we want to do with our KEQ in this particular question is we want to have KEQ is equal to the concentration of our products. So the concentration of Ca3PO4 2. And we want to multiply that by then the concentration of the other product, which is NaOH. And we use the square brackets to communicate we're talking about concentrations. The last thing that we want to do is whenever we have balancing coefficients, we want to raise those to the power of whatever number we have. So because we have a balancing number of 6, it'll be NaOH to the power of 6. And then on the bottom, we want to put the concentrations of our reactants. So CaOH2. And that has a balancing coefficient of 3, so we'll cube this concentration. And then we have Na3PO4. And that one has a balancing number of 2, so we'll square that. And this is what the KEQ expression for the above reaction is. We have the two products with them being raised to the power of their balancing numbers, the two reactants in the bottom with them being raised to their balancing numbers as well. And generally we'll be given the concentrations, or alternatively we'll just be given the KEQ and be asked to figure out what these concentrations might be at equilibrium. And that is your introduction to KEQ.